My people, we are back together yet again. Some of you, this is the second video you've watched in probably the last 30 minutes. What an awesome experience to get to spend this much extra time outside of class together. I feel lucky. I hope you feel lucky too. We're going to get the second part of our lesson on 8.6. Again, we're in 8.6. If you're watching this video, you probably already have this document downloaded because you watched the video that I did for solving rational equations. You saw that first. But here we're going to do inequalities. Okay, so again, if you don't have this downloaded yet, some reason you're watching this one first, stop what you're doing, okay, and get back on Remind. I sent you a link to this via Remind. If you're not enrolled in the Remind or something happened, you can also download this document from my website. You can get to my webpage through the Stratford High School homepage. Find my name, Ryan Kozad. It'll be one of the first things that you see there, okay? So download this, print a copy, get it out, and go through it with me, okay? All right, here we go. So let's talk about solving rational inequalities. Now I'll tell you, solving rational inequalities is a little bit more tricky, a little bit more hairy, a little more spicy than solving rational equations. There's a few other things that are just a little strange about the way we do this. But again, I've tried to break this down to 3 easy to follow steps that apply to just about every single rational inequality you're ever going to see. So here we go. Let's go through our steps here. So step 1. Step 1 is find any x values that are excluded or off limits. Any x that makes a denominator equal 0 should be excluded. Okay, so here's what that means. I'm going to scan the inequality that I'm given here, and I'm looking just at the denominators, okay? And I see here that I only have one denominator that has a variable term in it, okay? So I know that x minus 2 can never be 0. So in turn, that means that x can never be 2. So 2 is an x value that is considered to be excluded. It's off limits. You can't use it because if you tried to use x equals 2, you'd plug it in this equation and you'd have a problem because you'd have 1 divided by 0, and mathematically we can't do that, okay? So in this case, there's only one x value that's excluded. Some of the problems that you're going to work on could have 2 or 3 x values excluded. Some of the problems that you work on might not have any x values that are excluded. But for the most part, you're going to have at least 1, maybe 2, maybe even 3 x values that are excluded off the bat, again, because you just figure out which x values make denominators 0. Again, you don't care at all about numerators here. You're just looking at your denominators, okay? All right, now we move on to step number 2. Step number 2 requires you to have watched the first part of 8.6 on solving rational equations, okay? If you haven't watched that yet, I would pause it here, and I'd go and watch that other video first, okay, because I walk you through the process, 3 steps again, of solving rational equations, okay? But here we go. In step 2, we're going to solve the inequality just like an equation. In fact, I'm just going to write this inequality as an equation, and I'll get the inequality symbol later. I'll pick that back up later. So I'm just going to even think about it and write it out as an equation. Now, the first step to solve a rational equation is you want to get one fraction equals one fraction. Okay, so here, this is where I have an issue on the left side of the equal sign. I want to get those 2 fractions to be the same. So when I'm picking my least common denominator, I know that I'm going to need to have a 3, and I know that I'm also going to need an x minus 2. Now again, I'm not going to, you could probably, if you wanted to, write 3x minus 6, but my experience has shown me that I like to wait on my denominators, especially until the very end, to distribute anything, because I'm looking for factors that could potentially cancel out. Okay, so I'm going to just leave it as 3 times x minus 2. If you wrote it as 3x minus 6, totally fine. No problems with that. Okay, so here we go. Look at this first fraction. X over 3 is missing the x minus 2. So that means I need to take this x and multiply it by what? Say it out loud. Don't be embarrassed. Nobody's watching. Okay? If you said x minus 2, you were right. If you thought x minus 2 and didn't say it, don't be shy. You're not too cool for this. All right? So here we go. The second fraction, 1 over x minus 2. What is it missing in its denominator? Hopefully this time you actually said 3. Okay, and you'd be right. So I multiply this by 3 over 3. So I've got minus 3 times 1 equals x plus 1 over 4. X plus 1 over 4. Okay, so now what I'm going to do is I'm going to clean up my numerator here. So I have x squared minus 2x minus 3 all over 3 times x minus 2 equals x plus 1 over 4. Step 1 on solving that equation is complete. 1 fraction equals 1 fraction. Now the next thing that I had you do when you're solving equations is I had you cross multiply once you get 1 fraction equals 1 fraction. Now before we even do that, I see a quadratic trinomial that I'm going to see if I can factor. Two numbers that multiply to -3 that add up to -2. That's going to be x minus 3 times x plus 1. So I have x minus 3 times x plus 1 over 3 times x minus 2 equals x plus 1 over 4. So now I'm ready to cross multiply. So I have 3 times x minus 2 times x plus 1 equals 4 times x minus 3 times x plus 1. Okay? Now some of you are probably wise enough to know that we can actually cancel the x plus 1 and the x plus 1. Okay, but here's where I need to pause for just a minute and give you some caution. If you cancel out the x plus 1 and the x plus 1 here, that is okay, but you have to remember that the x, set that factor equal to 0 and solve, so you get x equals -1. You're going to need to remember x equals -1 because that's actually going to, when we get to step 3 and we draw our number line, x equals -1 is going to be an important point that needs to be on our number line. Okay, basically our number line is going to be a collection of unique important x values in the context of this problem. The first x value that's going to be on our number line is x equals 2. The second number in this case, if you cancel out the x plus 1 and the x plus 1, which I'm going to do, okay, the second important point on our number line is going to be x equals -1. So what I want you to do is write yourself a note to remember x equals -1. Remember x equals -1. That's going to be another important point on our number line. Okay, so here we go. Here's what we have left. We have 3x minus 6 equals 4x minus 12. Subtract 3x on both sides, add 12, and I get x equals 6. Okay, so in the context of our work here, we've encountered 3 special x values. We've encountered x not equal to 2, but that's one of the special values we've encountered. We encountered x equals -1, that's the second special value. And then we've encountered x equals 6. So that's important to pull out all the special x values that you can. Okay. Now step 3 is where students really kind of start to struggle. So really bear down and pay close attention to what we do here. Okay. Step 3 says set up a number line using any excluded x values and solutions you found as critical points. Then test a point from each section of the number line. So here's what I mean by that. Okay, so I'm going to set up a number line here. And we have 3 critical points that need to be on that number line. 2, -1, and 6. Now when you write them out, please make sure that you put them in the correct order, numerically, -1, 2, and 6. And then what I want you to do is I want you to look at this, this section of your number line here. And you essentially have 4 sections. 1, 2, 3, 4. You have 4 sections. The next thing that you're going to do is you want to pick a point in each of these 4 sections to test the original inequality. Okay? So what is a number to the left of -1 that would be pretty easy to work with? Okay? I think -2 is probably a good number to work with there, so we're going to test that. A number between -1 and 2 that would be able to test, so a number that's between -1 and 2 that's easy to use would be 0, or 1 if you wanted to do that. Here we've got a number between 2 and 6 that is easy to test. I'm going to just go with 4. You could probably go with 3, but I kind of like even numbers over odd numbers, just personal preference at this point. And then a number bigger than 6, let's just go 8. Again, you could do 7 or you could do 10. 8 for me, like I said, 8 is just pretty close to 6 and it's an even number. I like to deal with that. So here's what you're going to do next. You're going to take each one of those points in each one of those regions, okay? And you're going to test that in the original inequality. So here we go. I'm going to go from left to right. So I'm going to plug in -2 for x in the original. So I've got -2/3 minus 1 over -2 minus 2 is less than -2 plus 1 over 4. Okay, so that's the first one I'm testing. So I get negative 2/3 minus 1 over negative 4 is less than negative 1 over 4. Okay? All right, so I need to clean this up here. I use denominators of 12. Okay, so I've got, I multiply this by 4, so this would be negative 8 over 12. Minus negative, I'm going to go ahead and turn that to plus. Plus 3 over 12 is less than, multiply this by 3 over 3, so I get, what do we get? We get negative 3 over 4. I'm sorry, negative 3 over 12, my bad. Okay, so I got negative 8 plus 3, so this turns into negative 5 over 12 is less than negative 3 over 12. Okay, so you want to now evaluate, is this a true statement or a false statement? This is actually a true statement. You might be saying, well, that doesn't make any sense, okay, because 5 is bigger than 3. You're right, but we've got negative numbers. So negative 5/12 is actually less than negative 3/12. So what I do is I go back up here to my graph, and for section 1, I'm going to put a check next to section 1. That section is true for this inequality. Okay, so then what I'm going to do is I'm going to move on to another point. I'm going to plug in 0 and do the same thing. Okay, so this one's actually going to be a little less work. Okay, so I've got 0 over 3 is going to be just 0. Minus 1 over 0 minus 2 is less than 0 plus 1 over 4. So I have 0 minus 1 over negative 2, which is just going to turn into plus 1/2, is less than 1/4. So now you're asking yourself, is 1/2 less than 1/4? And that's not true. That's not a true statement. So that means section 2, put an X next to that. It's not going to be part of my final answer, my final inequality here. Okay, so I got 2 more sections to test. So now I'm going to do my test point of 4. So I'm going to plug 4 into X. So I have 4/3 minus 1 over 4 minus 2 is 1 over 2 is less than 5/4. Okay, so I'm going to use a denominator of 6 here. So I'm going to just keep kind of going right over here in my work. So I have 8 over 6 minus 3 over 6 is less than 5/4. So I've got, this translates to 5/6 is less than 5/4. That is a true statement. Okay, 5/6 is less than 5/4. Okay, 5/4 is more than 1, 5/6 is less than 1. So section 3 on my number line gave me a true statement as well. So there I've got 2 true statements, and I've got 1 more to test. I've got x equals 8. Okay, I'm running out of room here. You probably are too, and some of you are probably really mad at me that I didn't make this box bigger, but I tried to get it all to fit on one page. Okay, so let's test this last point here. Let's test x equals 8. Okay, so I have 8 over 3 is 8/3 minus 1 over 8 minus 2 is 6 is less than 8 plus 1 is 9. That's 9/4. Okay. So I'm going to look at 3, 6, and 4, and I'm going to do all denominators of 24. So I'm going to multiply this one by 8 over 8, so that's 64 over 24 minus 4 over 24 is less than, so this would be times 6, so that would be 54 over 24. So 64 minus 4 is 60 over 24 is less than 54 over 24. And hopefully it doesn't take you long to reject that and say, no way, that's not true. 60 over 24 is not less than 50 over 24. So that section is false as well. So there we go. We've tested all 4 sections of this inequality. Now what in the heck do we do with that? Okay, so here's what we have to do. We have to write out our inequality, and it's going to actually have 2 parts. Okay, so here's what it'll look like. We know that x can be less than -1, or x can be between 6 and 2. So that's what your final answer would look like. That's what your final answer would look like. There's actually 2 parts here. X is less than -1 is the first part that we tested. We got a true statement. And then the second section that we tested to get a true statement was x is between 2, bigger than 2, but less than 6. So there you go. That is probably a little overwhelming for a few of you, but I promise you you're going to be fine. If you need to go back and listen or watch to this video again to kind of see what we did, I think you probably got confused with the number line portion. Okay, but again, once you get your critical points, -1, 2, and 6, those are just all the special x values that show up in your work. You're going to test as many test points as you need for each individual section and just answer the question, do you get a true statement or a false statement? And then at the very end, you just you write out all of the true statements as an inequality, and that's your final answer. Okay? So at the bottom of this page are 4 more practice problems that you can work on by yourself now. I have an answer key for you in class that you can check and see how you're doing on this. But hopefully this clears up a little bit confusion. Again, I know this is probably overwhelming for some of you. Just relax, you're going to be fine, okay? If you need to rewatch the video, totally fine. You can probably pick up right where I start on step 3 and walk through that again. Okay, I probably went a little faster than some of you did as well. So if you need to just kind of go back and take your time through this, that's totally fine with me, okay? But there you go. That's all that I have for you for 8.6. The rest is history. We're actually done with chapter 8 after this, and we'll be able to get ready for our test next week. All right, guys, have a great rest of your day, and I'll catch up with you later. Bye, y'all.